Introduce the chair and the speakers. Rear Admiral Sanjay Adana, VSM, Assistant Chief of Material Modernization, Naval Headquarters, joined the Indian Navy in 1993. On staff, he served as Additional Command Engineering Officer at Western Naval Command and Command Technical Officer Marine at Andaman and Nicobar Command. At Naval Headquarters, he was Deputy Director of Marine Engineering, Joint Director Ship Production, Technical Advisor to Chief of Material and Helm as Commodore Dockyards. In his base appointment, he commanded INS Exila at Vishakhapatnam. He is an alumnus of College of Defense Management and has also served as directing staff at CDM. In addition to ACOM, he is also Director General Naval Trials and Acceptance Authority. Commander S.S. Ghatge was commissioned into the Aeronautical Engineering branch of the Indian Navy in 2001. He served as STO in INA S315 and has also served as Senior Engineer Officer on INS Aditya and Engineer Officer on INS Jyoti. Shri Gopi G. Scientist F. Defense Research and Development Laboratory, DRDO. He is currently heading Internal Fabrication Division and Center for Additive Manufacturing. Over to Rear Admiral Sanjay Adana.
Good afternoon, everybody. So we are going to discuss this important topic of corrosion-resistant composites and additive manufacturing for naval survivability. So what I feel is we actually are at a very, very pivotal moment where the convergence of the subject of material science and digital manufacturing is actually redefining what can be done in the aerospace and defense space. The advanced materials ranging from high-performance composites to the next generation super alloys are actually enabling products that are much lighter, much stronger, and they are much more resilient in comparison to the products which are made through conventional processes. At the same time, 3D printing is transforming the way we design, we produce, and we sustain these products. Actually shifting the traditional supply chains to the ones which are more agile, which are more, so to say, decentralized, and they are actually on demand. So insofar as the armed forces are concerned, these digital manufacturing technologies are not just for efficiency. These technologies are aiding them in operational readiness. They are providing them with the strategic autonomy, and they are also improving their ability to respond to and respond very swiftly to the dynamic environment in which they operate. And for the industry, this field opens up frontiers of innovation, customization, and also cost optimization. While these advancements in material technologies, the additive manufacturing they've been providing a lot of opportunities to the field of aerospace and defense, but they also pose certain questions. And the foremost question that comes to mind is that when we fit these items or products which are made through 3D printing into the equipment and systems which are mission critical, how do we ensure the certification and reliability of that system? And during course of presentation, my colleague Shri Gopi will try and answer that. The second question is about the scalability. From the prototyping to its deployment, how do we actually ensure the scalability of these products? And the third question, which is again very, very relevant, is how do we build a robust ecosystem which fosters an environment wherein a rich collaboration happens between the military, the industry, and the academia. When I say academia, I also include DRDO in that. To explore these perspectives, I've got a fantastic panel of subject matter experts with me who would bring in their unique insights from their domain experience. So first, I would like to invite Shri Gopiji to speak on qualification challenges and certification considerations for additive manufactured components for aerospace applications, right? Yes. So this is the subject Shri Gopiji is going to speak. While he walks to the podium, I would request Mr. Gopi to also try and answer as to what breakthroughs in the advanced materials are most promising for the next generation defense and aerospace platforms. Over to Mr. Gopi.
Okay, good afternoon, everybody. First of all, I would like to thank CAPS and the organizer giving me the opportunity to share my thoughts during the presentation. Since morning, many of the speakers were talking about this certification, qualification certification. Basically, majority of almost Air Force has did produce around 400 components. Morning that was mentioned, some speaker was mentioning that 400 components they made it. But out of all the 400 components are non-critical components, because there the qualification requirements are not stringent. It can be that to part basis, basically maintenance MRO kind of thing, you have to maintenance repair kind of part basis. Suppose if you want to make a component, mission critical component, that too you wanted to make a mass produce that, or batch production if you want to do, then the qualification of and certification is very important, especially for mission critical aerospace application. Today I will talk on that, what are the difficulties and challenges. It is not so critical, it's not so easy qualifying and certifying the components made through additive manufacturing for aerospace application. Let us see this. In metal additive manufacturing, basically it's a complex special process, basically, like a welding, other kind of thing. It has got so many process variables. You can see a lot of process variables are there. I think screen are not coming up. Okay. Right from material and process parameters, so many variables are there. These variables, since variables are huge, which are very critical to quality, which can be posing a challenges in challenge in qualification of the component. Another one issue is because many manufacturers, machine manufacturers are there, these are all not standardized. See, if you see this tool path and a scan path, every machine manufacturer, they have got their own algorithms. That is also not standardized. That's why if I print up one part in one machine, if I print the same part in another machine, the qualification thing again to be repeated. It is not so. That is not non-standardized. The current qualification approaches are developed for other manufacturing processes. That is not exclusively for additive manufacturing. These are the challenges are there. See, what is the advantage of additive manufacturing? Why aerospace applications are looking to the additive manufacturing thing? Basically, speed, low cost, and improved performance, supply chain robustness. That is the four more factors. It is making them to move towards the aerospace companies move towards this additive manufacturing route. See, one is as a defense laboratory, as development laboratory, majorly we are focusing on rapid product development, our cases. In addition to that, we want to do a part consolidation. These are the four major things we are doing that. See, one classical study I want to present, the GE. GE's one thing is, majority in the last 10 years, they used to say the LEAP engine nozzle. That is the one gold standard for additive manufacturing. Almost GE and DS made almost lakhs of nozzles are there. Only that lakhs of nozzles are printed through additive manufacturing. That is one gold standard. Another thing GS did is this CT engine. This one frame of the CT engine, they made it, converted 300 parts into one part. It has become a single part. That otherwise, conventional would consist of 300 parts. It become one part. The number, it has got 7 different assemblies. It's become one single assembly. Once you reduce the number of parts, your inventory and supply chain, everything will easy to manage. Then your product quality also will improve. Similarly, other engine, that is a catalyst engine. It's a complete engine that has been qualified by GE. See, that engine, entire engine was almost 855 parts. That has been reduced to 12 parts. But it has not been done in one day or 2 days. GS took almost 10 years to do that. 10 to